going to take a look at how to find key features of a graph based on its rational function. So we're going to find any x-intercepts, any y-intercepts, and any excluded values. I'm going to start by finding x-intercepts. Remember, when I find x-intercepts, that means I'm plugging in 0 for the y value. In this case, I'll plug in 0 for f of x. So I will have 0 equals 4x plus 8 over x squared plus 6x plus 8. And then I'm actually going to write this as 0 over 1 so that I can see that to find my x-intercepts, I'm going to end up cross multiplying. Before I cross multiply though, I want to reduce this right-hand side as much as I can. So I can factor out a GCF of 4 here. That would leave me with x plus 2. And then factors of 8 that add to 6 would be 4 and 2. So this factors into x plus 4 times x plus 2. And I have a common factor of x plus 2 on top and bottom. I want to reduce that factor out before I cross multiply, and we'll talk more about that when we get to our excluded values. So at this point I have 4 on top and x plus 4 on the bottom, so I can cross multiply. So I have 1 times 4, which is 4, equals 0 times x plus 4. Now 0 times anything is just 0, so I end up with 4 equals 0. Now that's not true. And I have no x's left to solve for here. So that means our function has no x-intercepts. So let's take a look at our y-intercepts. To find the y-intercept, that's where I plug in x equals 0. Again, for our x-intercept, we plugged in y equals 0. For the y-intercept, we plug in x equals 0. So I'm going to plug in 0 anywhere I see an x in my function. So that would be y equals 4 times 0 plus 8 over 0 squared plus 6 times 0 plus 8. This over so you can see. So this first term is 0, and then 0 and 0. So I'm left with 8 over 8, which reduces down to 1. We have a y-intercept at 1. The last thing we'll find here are the excluded values for our function. So remember that excluded values are asymptotes or holes, places where our graph does something strange. So to find our excluded values, we focus on the bottom of our function. Excluded values come from when the bottom equals 0. So I'm going to take a look at the bottom of my function. In factored form, I know that that would be x plus 4 times x plus 2, since we already factored that when we were finding our x-intercepts. And so I know that if I set each of these factors equal to 0, I can find the x values that, if I were to plug them in, would make the bottom of this function equal to 0. So that would be -4 and -2. I classify these values by taking a look at the top of my function. And I'm going to look at the top in factored form. So I can pull out a GCF of 4 here, which we know since we already did this. 4 times x plus 2. I now look to see if there are any factors that I could have reduced. Again, since we already found our x-intercepts, we know that we could reduce the factors of x plus 2. Any factor that I could reduce, which gives me an excluded value, is going to be a whole. So I know that x equals -2 is a whole. If we hadn't reduced at the start of our problem, we actually would have found x equals -2 to be our x-intercept. But if I were to look at that on the graph, what I would find there is a hole in my graph. Now, my x plus 4 factor is not reducible. I don't have another factor of x plus 4 on top that I can reduce. So that means that this factor results in an asymptote. So I have an asymptote at x equals -4. I have a vertical asymptote there. Make sure that you do include the x equals portions of each of these, particularly for the asymptote, since that is a whole line that we're describing on our graph. So it is important that I have the x equals portion there.